percent composition. So you take the mass of the element, divide it by the mass of the entire compound, and multiply it by 100. Another way of looking at it is part over whole times 100. You may be asked to find the percent mass of something besides an element in the compound. For example, if it's a hydrate, you might have to find the percent mass of water in the hydrate. Or you might be asked to find the polyatomics mass percent. So it's not just for elements. If they don't specify a specific element or compound or polyatomic to find, then you need to do each individual element in that whole compound. In 1987, the first substance to act as a superconductor at a temperature above that of liquid nitrogen, which is 77 Kelvin, was discovered. The approximate formula for this substance is YBa2Cu3O7. Calculate the percent composition by mass of this material. So we're not specified to one of our 4 elements, so we need to find the percent mass of all elements. So the first thing we want to start with is simply the mass of the compound itself. So yttrium has a mass of 88.9 grams per mole. 2 bariums, so 2 times 137.3 grams per mole, plus 3 coppers, 63.5 grams per mole, plus 7 oxygens, 16.0 grams per mole. And we're going to add that all together. And we happen to get 666 grams per mole. Make sure that you have a unit with your number. Alright, so for yttrium, we would say 88.9 grams per mole divided by 666 grams per mole times 100. So we get 13.3%. Now, because we're dividing a mass by a mass, our grams per mole is going to cancel out, so it's just a percentage. You do want to specify what element or polyatomic or water or whatever it is that you're doing for that percentage. So then for barium, we had 2 bariums, so we need to take that into account when we do the mass of barium for this compound, divided by the mass of the whole compound, times 100. So we have 41.2% barium. Same thing with the copper. We had 3 coppers, so we'd say 3 times 63.5 grams per mole divided by 666 grams per mole times 100. And we would have 28.6% copper. Alright, for oxygen, because oxygen is our last element here, what we can do, since percentages always add up to 100, is we can take 100 and subtract our 3 percentages to get our percent of oxygen. So oxygen has a percentage of 16.9%. There are 2 different formulas that you should be able to calculate based on mass percents, and that's the molecular formula and the empirical formula. The empirical formula is the smallest whole number ratio, and the molecular is a multiple of that. You can use the molar masses of the 2 formulas to figure out the multiple. So based on the calculations of 100 grams of the compound, so that our percent mass is the grams if we assume 100 grams of the compound. Determine the moles of each element, divide each by the smallest, multiply by an integer to obtain whole numbers. That's not always needed, but if you have a 0.5, a 0.3, or a 0.6 after dividing by the smallest, you do need to multiply. So this is not always taught in Chem 1, so especially the 0.3 and the 0.6. Make sure you're aware of those values. Alright, so we have a white powder analyzed and found to contain 43.64. So we're going to assume we have 100 grams, so that our percent, 43.64, is our grams of phosphorus. And we're going to convert it to moles of phosphorus. Make sure that you have units written down next to each number, and you can show canceling out of grams, and we're left with moles. The other thing I would caution you about is when you do convert to moles, of rounding too much. You do want to try and keep your sig figs correct. 56.36 grams of oxygen. Convert to moles of oxygen. Gives us 3.519 moles of oxygen. So then we're going to divide by the smallest, which is our phosphorus. Alright, so when we divide our oxygen, this is what I was talking about as far as being careful about those numbers and having to multiply by an integer. When you divide oxygen by phosphorus's value, you actually get 2.5 oxygens. You can't have that 0.5, so we're going to multiply both oxygen and phosphorus by 2. So really we have 2 phosphorus and 5 oxygens. So when we put it together, it's P2O5. Now that's my empirical formula. I need to find the molecular. So you take the molar mass that they give you, and you divide by the empirical molar mass. So 2 phosphoruses and 5 oxygens has a molar mass of 142. And so you have 2 as your multiple. So you have 4 phosphorus and 10 oxygens. Alright, if we look at another example, we have analysis of a chemical indicates that it has a composition of 65 carbon, 5 hydrogen, 29% oxygen. So here we have 3 elements, but the process is still the same. 65.45 grams of carbon, .45 grams of hydrogen, and then 29.09 grams of oxygen. We're going to divide by the smallest. So we have 1 oxygen, 3 hydrogens, and 3 carbons. So my empirical formula is C3H3O. Now they give us a molar mass of 110 grams per mole. I want to find my multiple, so 3 carbons, 3 hydrogens, and an oxygen has a molar mass of 55 grams per mole. So again, my integer is 2. So we'll say C6H6O for our molecular formula. Another type of question here, instead of giving you the percentages, they could tell you about a combustion. So here we have a hydrocarbon that's undergone combustion to form carbon dioxide and water. Well, a hydrocarbon contains hydrogen and carbon. And when it's combusted, all of the carbon goes into carbon dioxide and all of the hydrogen goes into water. So we can use our mass of carbon dioxide to actually find how much carbon we had. So first we want to convert it to moles. And then if we look, 1 mole of carbon dioxide, so 1 carbon dioxide has 1 carbon. So that would give us 4.165 moles of carbon. Since hydrogen all goes into water, we can do the same thing there. 94.23 grams of water. For every 1 mole of water, we have 2 moles of hydrogen. So watch out for that 2 moles. For carbon to carbon dioxide, it was 1 to 1, but hydrogen and water, it's a 2 to 1. And then we're going to divide by the smallest. So that gives us 1 carbon and 2.5 hydrogens. Watch out for that 0.5. We'll have to multiply both by 2 to get rid of the 0.5. So we have C2H5 as our empirical formula. So to find the molecular formula, we would take the molar mass that they give us, 58 grams per mole, and divide it by the molar mass. 2 carbons and 5 hydrogens is 29 grams per mole. And again, that gives us an integer of 2. Now the integer is not always going to be 2, so you do need to still divide here. And we have C4H10 as our molecular formula.